So now we want to talk about SP hybridization. We're still talking about hybridization. We've talked about SP3 in another video, and then the video before this, SP2. And now we want to talk about SP hybridization. So SP hybridization. So what we want to talk about hybrid, we are going to start from the same place. By now, if you've seen my other videos, it would be much easier for you to understand this. So again, we are going to start with the electronic configuration of the ground state of carbon, and already people know what the ground state, what I mean by the ground state. If you don't know, go to my to watch my videos. So yes, so electronic configuration is going to look like this. The ground state. Okay. So this is what it is going to look like, and this is the ground state of carbon. Ground state. And what happens is that in the next stage we are going to have promotion, and we have already mentioned that promotion, it is when this electron is this 2s electron is promoted to this level, to this orbital and to the p orbital. So what we are going to have is this, we're going to have something like this. I don't know what happened there. Let me undo that. So that we'll have something like this. And then what's going to happen is that the electrons that we are talking about, this electron, the electron that was here is going to be promoted to the p orbital. So what we have now is that this electron now has been promoted to this orbital. That's why we are going to have this configuration. But what happens is that this is going to be taken to another level, and the orbitals are going to be hybridized. And when they become hybridized, what is going to happen is that this electron, this orbital, let me use the same color, this orbital that is here, that is on the s orbital, and one of the p orbitals are going to be hybridized. So what is going to happen is that we are going to have a situation whereby we have these electrons, and these are not there, right? So these are the hybrid orbitals. These are the hybrid orbitals. So these are the hybrid orbitals, and as you can see, is that there is 2 electrons in there. So it means that there's going to be 2 electron directions, and what is going to happen is that because there's 2 electron directions, it means that we are going to have a linear shape. So the shape is going to be linear because we've got 2 electron directions, and therefore it means that the angle is going to be 180 degrees. So this is what we have actually gleaned from this. So how is this going to look like then? This is what is in a molecule. So in a molecule, a good example of the molecule that we can give is actually ethine, right? So in ethine, what you need to know is that ethine looks like this, right? It's got this formula, and as we said that we have got 2 electron directions, and therefore we have our carbon here, right, and another, and then electrons that are going in the other direction, and then we get another carbon and electrons that are going in that direction. So we have got this electron direction and then this electron direction for this carbon, and then for this carbon we've got this electron direction and this electron direction. And this is the reason why we've got a linear, and this is actually 180. It is important to actually emphasize that. And how are the orbitals going to look like then? How is the how are the orbitals going to look like then? The orbitals are going to look like this. They're going to look like this. So we've got this orbital that is coming from this carbon, and these are going to be combined to form a bond, and then we have actually these orbitals that will look like this. And obviously what we need to remember is that they are electrons that are in there. So we've got your electrons that are obviously in there. But remember, we have actually said that these electrons are not in the bond, and let me use maybe a different color. They are not hybridized. And what happens to those electrons that are not hybridized, that are here? So what is going to happen is that these electrons are going to have, these orbitals are going to be positioned in this way. One is going to be positioned in this way, that is on the page, right? And the other one is going to be oriented in this way, so coming out of the page, right, or of the screen if you like. And what is going to happen is that, remember that we still have electrons that are in there. So we have electrons that are in here, and these orbitals, what is going to happen is that these orbitals are, of course, they are going to merge. They are going to merge, and obviously, and the green orbitals also will also merge. These will merge. These will merge. It's a little bit messy, but then it's like I said in the other videos, it's easy to actually understand. So that we are going to have your your bond that is in there, which is in here. We will have a sigma bond. Okay. And all of these will form will be a sigma bond, but the bonds that are formed with electrons that with merging of the orbitals, right, is actually will be your pi bonds. So in this case, we are going to have two pi bonds. So this will be your atomic orbital. This is your atomic orbital. Right. So let's look at the molecular orbital, how the molecular orbital is going to look like. Let me just do this quickly. I think by now you have an idea of what I am actually talking about. So your atomic orbital, your molecular orbital is going to look like this, right? So you have these electrons that are here, okay, that are hybridized, right? So what is going to happen is that we will have the other electrons that are going to overlap, and they're going to, no, they are going to merge. They will look like this, and then the other electrons will overlap and form something like this, right? And the other one is going to be at the back there. I'm going to try to draw this like this. It will be at the back. And it will be like that. So it is at the back. So with our purple orbital in the middle that forms the sigma bond, and the other orbitals uh, are going to be like this. Okay, like this. So we can add in our hydrogens. Our hydrogens are going to be here, obviously. These will be your hydrogens. No, it didn't work out the way that I wanted it to. So this will be your hydrogens. What does that mean, therefore? It means that we now have our sp hybridized ethine. Right, that's what it looks like. So this is actually your molecular orbital. This is your molecular orbital. Now, let's finish off. Right. So this is actually at the end of this, really. So what does it mean, therefore? Let me just clear this canvas. What does that mean? Well, if we summarize, we can summarize it by saying that our orbitals, therefore, in ethine will be sp3, trying to move quickly, sp3. And if when we have sp3 or hybridization, a good example is ethane. And in ethane, what we have is that we have got 4 electron directions, 4 electron directions. And since we have 4 electron directions, we are going to have a tetrahedral shape, right? And obviously what we are going to have is something that looks like this, right? So this is the shape that we are going to have, and we will have another one, which is obviously an sp2 hybridization. Good example is ethene, right? And in ethene, what is going to happen is that we will have 3 electron directions, and since we have got 3 electron directions, we are going to have a trigonal planar shape. And in the trigonal planar shape, we have a good example will look like so. This is trigonal planar, and it has got an angle of 120 degrees, right? So, and the last one that we talked about is actually sp hybridization, and in the sp hybridization, good example is ethine. And in ethine, what we have is 2 electron directions, and in these 2 electron directions, what actually is going to happen, I can't spell directions because I'm trying to directions, I'm wasting time there, directions. And in these 3 electron directions, we are going to have a linear shape. It is a linear shape, and the angle is obviously going to be 180, and this will look something like this. So we have a linear shape, and this will be 180 degrees. So so what are we saying? Let's look at a little bit of quiz quickly, a little bit of questions that might be so you might be asking, okay, I'm going to write an exam, so what will be the examples of questions that they're going to ask? And a good example of the questions will be, for example, what is the hybridization in C? Yeah, right. this will be a good example of a question. And what is the hybridization here in each of the carbons? So in each of the carbons here, obviously here what do we have? We have got 4 electron directions, and since we've got 4 electron directions, then it is going to be sp3 hybridized. So I've counted, this is 1, these directions are 1, 2, 3, 4 electron directions. And this is it's the same thing with here. We have got 4 electron directions, 1, 2, 3, 4, and therefore it is also sp3 electron directions. But on this carbon, we have got 1, 2, 3, so we've got 3 electron directions, so it is sp2 hybridized. So this is sp2, this is sp3, and this is sp3 electron directions. So let's look at another example. For example, in the nitri, like this. So we've got, this is an example of a nitri, and in an example of a nitrile, what is going to happen is that obviously we've got this in each carbon. All right, this is obviously going to be 1, 2, 3, 4, 4 electron directions, and since we've got 4 electron directions, this is going to be sp3, right? And on this carbon here, we only have 1, 2 electron directions. So since we've got 2 electron directions, then this is going to be sp hybridized. So this is sp hybridized, and this is sp3 hybridized. Then this is an example of a question. So this carbon, what will be the shape on this carbon? It is going to be linear, right? And the angle is going to be 180. And on this, it is going to be tetrahedral. So these are the examples of the questions that you can be asked. And with that, I think this will end this. If you've got any questions, you can actually write on them on the comment and just contact me, and I will be able to answer your questions. So yes, this video has been longer than I expected, but it has helped because we've looked at examples of questions. So thank you. See you in the next video.